Well, hello again everybody. Well, I'm sure you'll remember that a few weeks ago I actually did a little bit of a review of this very large 175 watt Weller soldering iron. And I'm sure that you'll all remember me using this big soldering iron to have a go at repairing the bases on some paraffin lamps I had. And I've got to admit, this soldering iron did seem to do a relatively good job of it. It was really more my inexperience at using it more than anything. But I actually also thought that the tip on it was a little bit too big. Now this soldering iron, I think these are about 60 or 70 pounds off the top of my head, and I did think when I bought it I could perhaps reuse this soldering iron for doing work on valve radio chassis. But unfortunately when I actually bought this soldering iron, I have to admit I actually totally underestimated quite how big this soldering iron is. It's an absolute monster. If I just compare it to my normal electronics soldering iron, just let me show you that. So here's my little paste soldering iron which I use for doing 90% of my electronics work, and if we see a little bit of a comparison between the two tips you can see that there's effectively a huge difference. I think this one's probably about 3mm and this one is nearer to 16mm across, so I actually think that this thing wouldn't actually be useful for soldering valve radio chassis. It's much too big. So just for comparison, here's a Lafayette radio that we took a look at last week. Now I'm actually thinking of changing the wiring to the valves here for the filament wiring. What it actually uses the chassis as the return, but where they've actually chosen to wire the return wire to, it actually goes in line with some of the other components on the valve. So I think that if we are going to use the chassis as the return line, we need to actually solder wire to the chassis rather than soldering it to another grounded component here, because it actually uses the centre pin as the valve of the ground, and this centre pin is actually only connected to the chassis via some rivets. So what I would like to do is, as I say, one side of the filaments I want to put on for each of these valves its own soldered connection back to the chassis. So if we just take a look at the actual soldering iron, you can see that it really wouldn't be very easy to do. This actual soldering iron it's bigger than the whole of the valve base, so I could probably get at that connection, but I certainly probably couldn't get at some of the other connections. It's just far too big, and I said that at the time. There's nothing wrong with the soldering iron itself, it's just too big for working with on a valve radio. So as you can see, I've gone ahead and I've actually bought a smaller soldering iron. Now I don't actually work on valve chassis very often. I work on valve radios, but it's not that frequently that I have to solder a wire onto the chassis. And usually I can just about get my paste soldering iron to do it because it is quite a powerful unit. But this soldering iron that I've bought is more powerful. This is a 100 watt version, and it's made by the company Antex. Now certainly Antex is a name that I'm very familiar with, and I seem to remember it actually quite fondly. I think my first soldering iron was an Antex iron, and there was a time that used to have the yellow handle on it. Now these soldering irons, they're actually fairly simple beasts. They're not temperature controlled. It just has a coil of resistance wires, and basically depending on the voltage that you feed into it, that's how hot it's going to get. And of course it is a little bit of a drawback that soldering irons that don't have a thermostat control, they do tend to run a little bit hotter, which I think can make them a little bit unsuitable for working on modern high density circuit boards where you've got very thin traces, and if you're not careful the heat from the soldering iron will lift those traces. So certainly if I'm working on electronics equipment, printed circuit boards, you want to use an iron that's thermostatically controlled. So what I thought we could do today is I thought we could actually take a quick look at this Antex soldering iron. I don't think it'd be fair to call this a review video because certainly I've got no particular expertise in soldering irons, apart from I'm somebody who's been using them every day for the last 30 years. So what I thought we could do is we could plug this soldering iron in and we'll give it a go and see how well it works. So the model number, I've just noticed it down here, it looks like we've got a HP 100 and the 100 stands for 100 watts. I'm guessing the rubber maybe means it's got a rubber lead, I'm not exactly sure, and it's 230 volts. So if you live in America or something, you would have a 120 volt version, something different to this anyway. And as you can clearly see, this soldering iron is branded Antex, but I did actually notice that you can actually buy this soldering iron from a number of different companies, and it will be branded differently. So I'm assuming that most of these all come from the same factory in China, and depending on what company actually buys them, they will put their own name on the handle here. So I don't actually think this is maybe manufactured by Antex, but of course, again, I'm not absolutely totally certain. So just looking at the side of the box here, I think that maybe they use the same packaging for a number of different soldering irons, because the 100-watt thing here is a label, and the 100-watt thing here is also just stuck on label. So I'm guessing that, again, from the information here, it looks as though they can supply this soldering iron or something similar to it in a 30-watt version, a 40-watt version, an 80-watt version, or the 100-watt version. And they're giving us some numbers here for the different types of tips that we can use. So I've gone ahead and I've bought the 100-watt version, which I thought was probably about the right size for doing valve radio chassis. And it's showing that it can come with either this straight tip here, and it's got a number on it, which is a B260030, or you can get one which I would call, I think you call that a swan neck, one that's bent over, and the number for that one is B260130. So yeah, there's just a 1 character difference. So this soldering iron comes in either the bent version of the soldering iron tip or a straight one. Now I've got to admit, one of the things that does concern me a little bit about this soldering iron is the shape of this tip here, which I would describe it as being a screwdriver tip, and I'm not really a fan of screwdriver tips. I don't really understand them. The problem with this screwdriver tip is actually the length of them, in that you really need a lot of copper mass to have a good soldering iron tip, and you can see that this actually wastes away to quite a thin point at the end. So in terms of heat transfer, the heat transfer is very good where there's a lot of metal involved, but because they waste the tip, because they thin it down as it goes to the end, it's whether or not this soldering iron can actually get its 100 watts of power actually out of the tip. We may have a lot of heat energy stuck back here where the metal is wide, where the soldering iron tip is quite thick, but as it comes to the end, it's harder to get that heat out because it doesn't transfer. You have thermal resistance, much like you have electrical resistance. So I don't know how well this tip works, but I guess we'll find out, won't we? Now, for reasons which are completely unknown to me, having watched some previous review videos, it appears that I'm meant to give you the dimensions for things right now. So yes, let's do that. So the length of the soldering iron from the end of the handle to the tip is 270 millimeters. Now, for those of you that are watching in America, well, really you should have bothered to learn the metric system, shouldn't you? The heating element here is 150 millimeters long. The tip on this one looks as though it's about 5 millimeters wide. Let's just confirm the width of the tip. So that looks like, well, about 5.5 millimeters. So I've got to admit, having worried about the thermal mass here and the thickness of the actual tip, it doesn't look too bad. There's actually quite a lot of copper here. So yep, that's well, that is 8 millimeters. Okay, there's no wibble wobble in the tip. It is just held on by a screw. I guess that's no particular problem. So the girth of the heating element itself is again about bang on 15 millimeters. And just looking at the finish on this, I'm pretty sure that this is manufactured from stainless steel, which is a nice kind of heat resistant material. And I think the tip itself is manufactured from some kind of coated copper. Now, just looking at the end of it, I can see that it's actually been very generously pre-tinned. So, you know, that's good, that's nice. And the approximate weight of our soldering iron handpiece is about 137 grams. And comparing that to my normal electronic soldering iron, well, it's about double the weight. So looking at the design for the handle of this soldering iron, I actually don't mind it at all. It feels quite nice to hold in the hand, and It's like triangular shape at this end here. It's kind of, what do you call it, tri-lobed, so you can kind of hold it in a pencil grip if you want to, and that's certainly not uncomfortable. It's that's not bad at all. Of course, when it comes to a soldering iron, one of the most important things is when it's been on for half an hour, is this handle going to get so hot that it makes it uncomfortable? Well, that's certainly one of the tests that we're going to have to do, isn't it? Now, we did take the weight of the soldering iron. I think we said it was 137 grams, and certainly given the size of the handle, that doesn't feel even slightly uncomfortable, so that seems good. And just for comparison, here's a big Weller soldering iron, which is a more powerful soldering iron. It's this one's 175 watt, but this one is actually quite hard to hold. I can actually feel this, actually putting quite a lot of strain on my wrist. This is really heavy, whereas in comparison, this weighs absolutely nothing. So of course, being a mains operated soldering iron, it does come with a mains cable on it, and it's got a similar style of cable to the Weller soldering iron. It's got the HO5RR-F cable. It actually doesn't feel super flexible. It's certainly nowhere near as flexible as a silicone lead. Again, if this was a very lightweight soldering iron, you would probably find that the stiffness of this cable would probably be a problem, because you would feel it kind of pulling against you when you were trying to do fine work. But on a soldering iron as large as this, where you're really going to be using quite a lot of strength in your wrist to manipulate it rather than just little bits of finger strength, I don't think you're going to find the lack of flexibility in the cable a problem. And taking a close look at the cable, it's actually got some information printed on it. So we've got an HO5RR-F, which is a tough rubber cable. I don't think this is a silicone cable, so it won't be entirely heat resistant. And then we've got 3G 0.75mm squared. So basically this is a 3 core, and each of those cores is 0.75mm square copper. And it's also got an IEC rating and various quality stamps. I don't really have any questions about these cables. I'm sure that it's a reputable cable from a reputable manufacturer. Certainly unlike some of the very cheap Chinese cables that we see on equipment. I'm not really going to doubt this. I'm sure that it is more than adequate for the job. So taking a look at the plug, of course, for no reason that I know of, it comes with a little plug condom, so we'll remove that because, well, why bother? Well, again, a little bit of information to tell us how to wire the plug, but somebody's gone ahead and wired it for us, of course. I guess we should check the fuse, shouldn't we? Let's do that. Okay, so it's got a 3 amp fuse in it, so that's good, which is more than adequately rated for this mains cable. And of course, fuses aren't really designed to protect the piece of equipment. If you get a fault, you know, your piece of equipment is stuffed, the fuse is there to actually protect the cable from melting and setting on fire. So I can't remember off the top of my head what a 0.75mm cable is, but it's certainly an awful lot more than 3 amps. So we haven't got any worries about the cable being man enough to actually blow the fuse. I wonder if we've got a well-made fuse in here. Has it got any British standard marks on it? Well, I absolutely can't claim to be certain, but it certainly does appear to be branded as a BS 1362 fuse. It doesn't appear to have any what I would call the kite marks on it or anything like that, but it looks reasonable. And of course it is good to see that we've got an earth wire employed, so hopefully the end of our soldering iron tip will be earthed. So that's coming up as 0.5 ohms, so I've got no doubt that that's good. And our soldering iron also comes with a little bit of bent tin, which I'm assuming we've got to gamefully employ as some kind of soldering iron stand. This really isn't filling me with confidence, this part, I've got to admit. Oh really, that is, really? Well, as you can see, that really is something quite special. Certainly is a thing. Well, I actually do have to say on a more serious note that this really doesn't impress me very much at all. I kind of just wish they hadn't bothered, because this does actually feel quite unsafe, and you know, it is a high power soldering iron. You don't really want to leave any soldering irons unattended, but you know, if this falls off your bench, and of course the last thing you want to do is try to catch a soldering iron, but you know, sometimes you drop something in it, it's human nature to try to make a grab for it. Well, you're going to end up being very badly burnt, and it's just not very stable, this. I'm sure you could, it might help to try to glue this down to something, but even if you did fix it down, yeah, it really just doesn't inspire any kind of confidence, this, does it? Well, as you can see, I went out into the garage and I bent a piece of tin, and I've made a little stand for our soldering iron now. So it's actually trapped on the taper of the handle, so it can't actually slide out. Now, I do actually think it is a bit of a fail, that other stand. It really is quite unsafe, because this is a powerful soldering iron. You don't want this dropping on the floor. It would be quite easy for it to start a fire or badly injure yourself. And yeah, that is actually a bit of a fail on the part of Antex. You know, they do supply a stand, but I don't know why they've supplied the stand in the form that they have done, because I actually think it makes a soldering iron unsafe to use. But that's just my opinion. Well, I think it's time that we gave this soldering iron a test, so we'll do what we did with the last soldering iron. We'll just put a piece of solder around the tip here, and when it comes up to temperature, this should melt and drop off and just give us a little bit of a visual indication of when it's kind of getting to the temperature that we can melt solder at. Also got a timer, and we've got our voltage cum watt meter here, so we can also take a measurement of what the power is of this soldering iron. Now, in theory it's a 100-watt iron, so we should be seeing 100 watts on the meter here. Okay, so I think we're about up to the operating temperature now, so or not far off it. So how long did that take? I think that was actually just under 4 minutes to reach its operating temperature. Or was it 3? No, sorry, I stand corrected. Just under 3 minutes to actually get hot enough to melt solder. And because this is a new soldering iron, let's give it a little bit of love and just tin the tip. Now, I have to admit, the tip on this does seem to be tinning much easier than the big tip on the Weller iron, so we like that. That's you know, that's a pass. So we're drawing 97 watts here on the power meter. So 97 watts. This is a 100-watt soldering iron, so you can see it's actually doing pretty much what its rated power is. So we're happy with that as well. Well, this soldering iron's been switched on about 10 minutes now, so let's just check the temperature. So the temperature of our soldering iron is about 540 degrees now, maybe going up a little bit more than that. And of course that is actually quite hot for a soldering iron. And as we said earlier, this actual soldering iron is not a regulated soldering iron, so unfortunately it is always going to be on the hot side. That temperature will drop slightly when we start to actually solder a radio chassis, something that's got some thermal mass. But unfortunately, if you're using a soldering iron which isn't regulated, it is always going to have to be somewhat of a compromise. But I don't actually mind that too much. At the end of the day, this isn't going to be used for soldering circuit boards where we could be lifting tracks. This is going to be used just for soldering radio chassis. And really, within reason, the more heat the better, so I'm not unhappy with that. The handle itself on the soldering iron is completely cool, which is good, even though obviously the hot end is absolutely red hot. The handle is completely cold, and yeah, it still feels comfortable to hold, so I'm pleased with that. That's very good. What I think we'll do is we'll just restart our timer, and we'll do a little bit of a soak test. We'll leave this on for half an hour, we'll come back to it and we'll check the temperatures again. Well, as you can see from the timer, our soldering iron's been on now about 54 minutes, and it's still drawing 96 watts. It's flicking between 96 and 97 watts. Let's check some temperatures again. So let's just check the handle first, right at the very end, which is the closest part to the heating element. Okay, I'm going to call it about 43 degrees. but the very end here is a little bit warm, but it's not, certainly not what you would call hot, and it's not uncomfortable, so there's not a problem getting hold of the soldering iron. The handle is doing a great job at providing some thermal insulation, so again, absolutely nothing wrong with that. That's working perfectly well. Let's see if we can measure the tip temperature again, see what it's settled down at. So the tip of our soldering iron, it's around 552 degrees. So again, it's on the hot side, but that's I don't mind that, that's fine. So I think for our first test, we're just going to have a go at soldering onto this piece of metal. Some of you might recognise this. This is the dropper resistors that we used when we were trying to replace the mains cord on the master radio. So these are the power resistors that are bolted to it. So it's just a piece of scrap metal, and I'm guessing that this is going to be fairly representative. Maybe it's a little bit thinner than a valve radio chassis. Let's just measure it. Okay, that's 1mm thick steel. So let me just give our soldering iron a wipe. We'll tin it and we'll give it a go. Actually, I forgot to wet my soldering iron sponge, and this soldering iron is actually so hot that it actually burnt the sponge then. So let's have another go. Actually, looking at this, when I actually put the flux onto it, the flux is actually burning. I can actually see little red spots, so that to me is implying that this soldering iron, it actually is too hot. It's actually burning the flux rather than actually just liquefying it. So I do think this soldering iron is probably too hot, and ideally it'd want to be running a bit colder than this. So, but let's carry on, and well, let's just see if we can solder our chassis. When I actually touch our solder here to the soldering iron tip, I can actually see it glowing red, you know, like it's been on fire, like burnt cardboard or paper. So it's actually too hot, it's actually burning the flux off. Okay, this soldering iron has absolutely no problems whatsoever putting the solder down on this piece of tin. I think the only problem is though, the flux isn't working too well, and the reason the flux isn't working, I think the soldering iron is so hot, it's actually burning the flux off before it actually has the opportunity to do its job. Now, back in the day, what you would do is you would go and get a lamp dimmer, a filament lamp dimmer, the kind you use on the you know, on the wall to turn filament lamps down in your house. So that's what we used to use back in the day to reduce the temperature of our soldering irons. I haven't got one of them, so I think what we'll have a go at is instead of using one of them, we'll go ahead and we'll use my Variac, and we'll just reduce the voltage down. And I think we want to bring the temperature really back to something closer to 400 rather than 500, because I'm fairly sure that what's happening here, it's just burning the flux off before the flux has a chance to actually do anything. I have connected up our Variac, and I've got the Variac set to about, well, it looks as though it's about 75% on here, which is 180 volts. Now in theory, because we've reduced the voltage, we should have reduced the wattage, so let's see what that is now. So the wattage of our soldering iron, it's now 50 watts. So before we were pumping in 100 watts of energy, but because we've reduced the voltage, we're only at 52 watts now. So let's give the tip a clean and let's have another go at soldering with it. And I've also just gone away and found my, I don't know if it's brass wool or stainless wool or something, but that works better than a sponge, I think. Okay, so that's lovely and clean now. Okay, that's a lot better. So when I actually put the solder on here, it's actually kind of clinging to, the solder is actually clinging to the bit, rather than just running off it immediately. And I can kind of see that the flux is hot, it's smoking, but the flux isn't setting on fire. So the flux was definitely setting on fire and burning before. Now it isn't. Question is, can we still solder with this iron? I think we will be able to fine. Yep, and it seems to have no problem whatsoever with that. Kind of thinking maybe the temperature could actually be a little bit hotter. We haven't checked the temperature, have we? Let me go back and just do that. Okay, so our soldering iron is around 405 degrees now, so it's certainly a lot cooler than it was. I think I might increase the temperature a little bit. Let's put that back up to 80% and give it a wipe and have another go. Of course, I haven't cleaned this metal. It could be a bit greasy. In fact, it's almost certainly going to be greasy. But again, yeah, absolutely no problem. And the flux is doing its job now. So the flux has actually got time to actually you know, prepare the metal, clean the metal. Before, when I was putting this rosin flux on, it was just burning off before it had the opportunity to do anything. So the solder joint here looks a lot better. It's much shinier than the solder joints were before, because they were short of flux. The flux was burning off before it had a chance to do its job. So this is a big improvement. So yeah, these temperature of these irons, it's a little bit over the top. You could do with calming them down just a little maybe. Well, our second victim for today is going to be this Lafayette radio that we saw in last week's video. Now I can see just by looking that the chassis is a little bit thicker. Let's just take a measurement. So that's about 1.5 mil steel. We've got our soldering irons set to the same voltage and temperature effectively, so let's give it a go. I have gone ahead and I've tried to clean the chassis there. I think we'll put a little bit of flux on this time. And here I'm going to use some no clean flux from MG Chemicals, so let's put a blodge of that on there. Now I have already cleaned up the chassis a little bit with a fiberglass pencil. So the first thing that I'm going to do is I'm just going to try to get some tin on the chassis. So we're not going to try and solder a wire, we're just going to tin it. Now apologies, I'm working around the tripod here, so this isn't very easy for me to do, but we will have a go. Certainly that was very easy to do. That was absolutely no problem at all. So I think the next test that we're going to do is we're going to remove this piece of braid from our variable capacitor, and this is quite a common job that you've got to do. We've all had to remove these variable capacitors from valve radios at one time or another, haven't we? We've had to take them apart to clean them or sort out a bent one of the bent plates on them. So let's see if we can just remove this. So again, I'm going to use a little bit of flux. Flux always makes things a little bit easier. So we're off. That came again off very easily. Let's see if we can put it back on again. Again, did a beautiful job, absolutely no problem whatsoever. So I'm just going to use a leg off this old mica capacitor here just to create the joint that we need. Put a little bit much solder on there, but I'm sure that will be fine. Now I think you'll be able to see that we made quite a reasonable joint there. The soldering iron certainly had absolutely no problem. We have actually got the voltage turned down a little bit, as we said. Let me just check what that is. Well, the voltage is actually turned down to 190 volts, but the wattage that the soldering iron is drawing is 60 watts. So we're using the 60 watts. The soldering iron is actually capable of running at 100. So I think, as you saw, this Antex soldering iron, it had more than enough thermal capacity to do what we wanted. I think it's really helped that the actual tip here is really quite a thick and heavy piece of copper, so we've got quite a lot of thermal mass here. We actually only use the soldering iron here at 60 watts. It could of course been run at 100 watts, but I think if you do run it at 100 you do run the risk, as I was finding. I was actually putting the solder on here, and it's a rosin cord solder, and I could actually see the rosin was burning. It was actually on fire, and you know, it was giving like a flame off red, so you couldn't see it on the camera, but I could certainly see it. So it was really just too hot. So it does need taming down. I think the other thing I've learned is when you're actually using a big soldering iron like this, it's probably really worth considering using some eye protection, because when you're using a little tiny soldering iron you don't tend to get, you know, real splashes of solder, but when you start putting you know, especially when you're doing things like this, cleaning the iron, it does have a habit of throwing solder everywhere, and you wouldn't really want to get a big blob of solder in your eye. That would be quite nasty. So as always, when you're using a soldering iron, really before we put it away, we want to try to re-tin it, just to stop the bit oxidizing. So there we go, we'll just put some tin back on there. Well, in summary, I think that this Antex iron is actually really good. It's actually a really good buy for occasional use on doing chassis work like this. It's too big for doing kind of circuit boards and what I would call, you know, general electronics. It's far too big for that. But when you need something that's got a bit of thermal mass, when you're trying to work on a radio chassis, I think this will be my go-to tool. You can of course spend much more money. I did also look at a Weller soldering iron. The Weller soldering iron, to get a temperature controlled one, that was about £100. To buy this Antex soldering iron, which doesn't have temperature control on it, I think this was £20. So you've got to bear in mind, I guess if you were using it every day, I would probably spend the extra money and buy the Weller with the temperature control. But for something which I'm perhaps going to get out of the cupboard once or twice a year, when I you know, it's not very often I actually have to unsolder something from a chassis, but when I do need to do it, I've now got the tool for the job. You might be able to justify spending more and getting a better iron, but I think that this is more than adequate for anybody who's undertaking valve radio repair work, as I like to do. The only thing that lets the soldering iron down is, well, I guess a couple of things. One is because it isn't regulated, it runs a little bit too hot, so I think you're going to have to run it off a variac personally, or you're going to use an SCR lamp dimmer. I think you've really got to do that, because yeah, it's no good, it just burns the flux off. If you can just tame the temperature down a little bit, it works very well. The other thing that was unfortunately a little bit of a fail is we saw that the stand it comes with is absolutely useless. In fact, I would say it's beyond useless, it's actually unsafe to use. So the first thing you want to do is you want to get that stand out, and you just want to throw it immediately in the bin and make yourself a new stand. But the soldering iron itself, I'm more than happy with it.